Hello students, in this video we are going to learn a very advanced level concept related to the projectile motion, which is angular velocity of the projectile motion. You see, projectile motion is happening in a parabolic path like this, but we are talking about angular velocity, which is a property of the circular motion. So the question is to find the angular velocity of the projectile when it is at the highest point of the path with respect to the initial point of projection. So with respect to this initial point of projection, means point O, you have to find what is the angular velocity of this particle when it is at the highest point. Now at the highest point of the projectile motion, is the velocity is zero? Students, what is your opinion? Think about it. At the highest point of the projectile motion, is the velocity of projectile is zero? So let's see. So the answer is that no, it is not zero. Actually, at the highest point, the velocity of the projectile is horizontal, tangent to this path, okay, horizontal direction, and value is u cos theta. Okay, let's proceed to find out its angular velocity. So since we have to find the angular velocity of the particle with respect to the origin O, hence O must act as the center of the circle. First, let us review that if there is a circular motion and a particle moves along this circle, then the velocity of that particle will be along the tangent direction to the circle, and O is the center, and the line joining from the center to the particle, that is the radius of that circle. And angular velocity will be defined as V by R. But here we don't see such kind of situation. There is no circle here. Okay, let us try to match one by one. This O is the center of the circle, and we have to find the angular velocity with respect to this origin O. So this origin O will act as the center of the circle. So let us draw an imaginary circle. Look at this. We have drawn an imaginary circle whose center is located at the point O, and the particle is also located on the circumference. So what will be the radius of this circle? Radius of this circle, this imaginary circle. So we should draw a line from O up to the particle P. So this line is the radius R. Let's say small r represents the radius of that circle. Now let us say this radius vector makes angle alpha with the horizontal direction. Now if we compare this diagram of circular motion with that of this imaginary circle, and we have to find angular velocity omega is equal to V by R, so we should find the value of V, but V is a tangent to the circle, you see. But in this projectile motion, the velocity is actually tangent to its parabolic path. The projectile motion, parabolic path, okay, tangent to this. But we require a velocity along this direction. If you want to find angular velocity, as per this formula, we should have the velocity along the tangent of this circle. So therefore, what we should do, we should now make the component of this velocity vector. We should find the component of this velocity along the tangent. So draw the component of velocity. Okay, we resolve both the components. One component is along the tangent and one along the radius. Now if this angle is alpha over here, same angle alpha will be this. And now the component of this velocity vector u cos theta along this direction should be u cos theta into cos alpha multiplied by cos alpha. This is the component along the radial direction, and along the tangential direction, the component of this velocity should be u cos theta into sin alpha. Regarding the concept that how to resolve a vector into components, I already have a video in my playlist. Under the playlist folder name is vectors. There you can find out the video how to resolve a vector into component. But in summary, I would like to tell you that whenever a vector is given and you make its two rectangular components, then the component which makes the angle with respect to the vector, that will be the cosine cos factor of that angle, okay, and the one which makes 90 minus alpha would be the into sin alpha. So like this way. But I recommend that you must see that video, then how to find the components of a vector. Let's proceed further. So now to calculate angular velocity, we have found the velocity which is tangential to the circle, which is u cos theta into sin alpha. This velocity divided by the radius r of this imaginary circle would be the angular velocity of this particle at this moment with respect to this point O. But we should also find the value of r. Let's see how to find the value of r. So this value of r could be found using Pythagoras theorem. If you see, this is a right triangle, and this small r can be written as the root of h square and plus r by 2 whole square. R by 2 is the half of the range of the projectile. So this maximum height h, we know the formula, u square sine square theta by 2g, and we also need to know this r. So the range formula, you know, it is u square sine 2 theta by g, and sine 2 theta can be written as 2 times of sine theta into cos theta. So now, using Pythagoras theorem, this radius r of that circle can be written as root of h square plus r by 2 whole square. Substitute the values into this formula. So u square sine square theta by 2g whole square, and this term, this range divided by 2, 2 will be gone, and only remaining things will be whole squared. Continuation here. So this becomes u power 4 sine power 4 4g square here, and here we get u power 4 sine square theta cos square theta by g square. So after squaring we get this. Now from both the terms we can take common things outside. So u power 4 common. From both terms sine square theta can be taken common, and g square can be taken common. So u power 4 sine square theta g square has been taken common. So remaining thing here would be sine square theta by 4, and here only cos square theta will remain. Both of these things are already gone. Now because of this square root, this term can be completely taken outside, and it becomes u square sine theta by g, and remaining things are this. We can now solve this. Little bit simplification can be done. So take the common denominator 4, this becomes 4 cos square theta. After that, as you know, sine square theta plus cos square theta is 1. So from this 4 cos square theta, we can take 1 cos square theta, and remaining 3 cos square theta can be taken aside. So now sine square theta plus cos square theta becomes 1. So we'll get 1 plus 3 cos square theta in the square root, and outside is the same. So here we also taken this common 4 outside the square root, so that becomes 2 in this step. So this is the value of the radius r for this imaginary circle. So now we are ready to substitute into this formula omega is equal to v by r to find the angular velocity. So the radius is this. Continue. Omega angular velocity is equal to v by r. Here v means this one, the velocity which is a tangent to the circle or perpendicular with the radius. U cos theta is sin alpha by r. Now we also need to know what is the value of sin alpha. From this triangle we can find out sin alpha. You know that sin alpha would be opposite side by hypotenuse. So for this angle alpha, opposite side is h and hypotenuse is small r. So h by r is the sin alpha. Substitute here, and we'll get this u cos theta into sin alpha h by r. So this small r becomes r square. Next step, substitute the value of h, maximum height, u square sin square theta by 2g is the maximum height formula, and this small r radius, this we already found out here, make it square. So we will get this u power 4 sin square theta 4g square, root will be gone. You get this. After this, the 4g square, you send it in the numerator over here. So the 2g will cancel 4g square, and u square into u will become u cube, and u cube cancel u power 4. So in the denominator will get a u. Okay, 2g cancel 4g square, we get 2g. This sin square theta cancel with this sin square theta, so only cos theta remains here, and this bracket 1 plus 3 cos square theta. So this is the final answer. This is the angular velocity of the projectile motion. So a very interesting thing is that, you know, students, we came to understand that angular velocity is not only defined for circular motion, but actually it can be defined for any kind of motion. We can have circular motion. In fact, a particle moving in a straight line also has angular velocity, and you must find out that that video is already posted in the playlist whose name is circular motion. So you please find that how to find the angular velocity of a particle that is moving along a straight line. Please do visit that video and see, and please write your comments under this video. Thank you for watching, and if you have come to the end of the video, please like the video and subscribe to my channel also. Thank you.